Section 6.6a is about graphing linear inequalities. We've already learned to graph linear equations. Now we're going to add inequality symbols, and it brings about a whole set of different problems. In this one, we want to look at something where it says, this set of points, we want to know which of these ordered pairs are part of a solution of this inequality. In other words, which ones work in the inequality and which ones don't. Well, the way you do that is you plug in x's and y's. So I'm going to take this inequality, 3 times x plus 2 times y is less than 12, and I'm going to plug in the ordered pairs. First we'll do 1, 6. So 3 times 1 is 3. 3 plus 12 is less than 12. Is that a true or false statement? Well, it's not. 3 plus 12 is 15. That's not less than 12. So 1, 6 is not a point that is a solution. Now we'll try the second ordered pair. 3 times x, x is 3. Y is 0, so this is 9 plus 0. Is that less than 12? And the answer is yes, that's true. So that's one of my solutions. I'll put it in blue. The next ordered pair, we have a 2 for x and a 2 for y. Plug those in. 6 plus 4 is 10. Is 10 less than 12? Yes. So this ordered pair is a solution. And the last one, 4, 3, 4 for the x, 3 for the y. We get a 12 plus 6. Is that less than 12? And the answer is no, it's not. So determining which ordered pairs are a solution, 3, 0, and 2, 2. Now I want to go over here to this graph and show you something. Now this graph, this line, is actually the equation 3x plus 2y equals 12. That's what this line represents. And I want to look at the points here. Let's go with 1, 6. Here's where 1, 6 is. Here's where 3, 0 is. Here's where 2, 2 is. And here's where 4, 3 is. I want you to notice something. The 2 points that make the inequality true are on the left side. The 2 points where it's false are on the right side. It turns out that every single point on the left side of this line will make this equation true. And I'm showing you that by shading all of the points over here. Likewise, every single point on the right side will make it false. Let's look at a couple definitions. A boundary line is a line that defines the edge of a half plane, and a half plane is the area formed when you divide a coordinate plane into two. So what's happening here is this dotted line is a boundary. It divides the plane into 2 spots. One half of the plane have the points that work in the inequality. The other half of the plane are all the points that don't work in the inequality. So now we're going to learn to graph an inequality on a plane. And the first thing we have to do, and I'll put this number 1, is you have to draw a boundary line. Well, if you're going to draw a line, you have to have an equation of that line. So what I'm going to do is I'm going to temporarily replace the less than or equal to sign with just an equal to. This line, this equation, is the boundary line for my inequality. So I'm going to isolate the y here. I'm going to add 2x to both sides. So this will be y equals, I'm going to write it as 2x minus 4, just because I like that in slope-intercept form better. So this is my boundary line. So I have to graph that. Well, to graph, I need ordered pairs, so I'm going to make a table. So think about this. If I plug a 0 in for x, 2 times 0 will be 0, and y will be a negative 4. Let's try a 2. I'll plug a 2 in for x. So 2 times 2 is 4, and 4 minus 4 is 0. Let's do one more ordered pair. How about a negative 2? Negative 2 times 2 is negative 4, and negative 4 minus 4 is negative 8. I like to do 3 points because it's the best way to do a graph here. So 0, negative 4, 2, 0. So those are the dots that make up my line. Now one more thing I have to figure out is, will my line be a solid line or will it be a dotted line? Now in this particular case, my boundary line will be solid because my symbol is less than or equal to. And it's that equal to. It's just like doing a filled-in circle. If there's an equal to involved, your line is a solid line. If not, then your line is going to be a dotted line. So we'll say the second step is to determine if the line is solid or dotted. And then the third step is to determine shading. And the way that you determine shading is you pick a point. And it can be any point. You can pick any point on the left side of the line or the right side. I like to pick the point 0, 0. That's my favorite point. And as long as it's not directly on the line, you can pick that point. And what we're going to do is we're going to plug it back into the original. So y minus 2x is less than or equal to negative 4. I plug 0 in for y, 0 in for x. And we say 0 minus 0 is 0. Is 0 less than or equal to negative 4? Is that a true or false statement? And the answer is false. So what we're saying is that 0, 0 is right here. It's on the bad side. It's on the false side. Well, we want to shade the true side. So that means we're going to take and we're going to shade the right side of this boundary line. And with your pencil, you can just do a light shading on yours. So that's how you determine shading. You pick a point, and if the point makes a true statement, that's on the good side, you shade that side. If it's the false statement, you shade the other side. So what we're saying is any ordered pair in the blue makes this inequality true. Any ordered pair over here in the white makes this inequality false, and that's how you graph it. Here's another inequality we're going to graph. Step 1, draw the boundary line. Replace the greater than symbol with an equal to sign temporarily, and then solve for y. Two y equals 4x plus 6. Divide everything by 2. Y equals 2x plus 3. So that's the line that I'm going to use. This time to graph it, I'm going to use a different method that we've used in the past. I'm going to use a y-intercept, or the y equals mx plus b, the slope-intercept form. My y-intercept is 3, and my slope is 2 over 1. So I'm going to go up 2 to the right 1, up 2 to the right 1. And I'm going to do ordered pairs there and there. Now I'm going to graph my line. Now, unlike my last line that I did in the last example, this one is going to be a dotted line. The reason it's dotted is because the symbol is greater than and not greater than or equal to. So there's my boundary line. The last thing is to determine shading. You determine shading by picking any point that's on here, doesn't matter, any point that's not on the line. I'll do 0, 0 because it's easy. So 2 times 0 minus 4 times 0 is greater than 6. 0 minus 0 is 0. Is 0 greater than 6? The answer is false. Since 0, 0 is over here on the right, that's the false side, I'm going to shade the true side. So I will shade the side of my boundary line that is true, where all the points that work in the inequality. And there you go.